Yesterday, I assigned for you a 10 by 10 grid, and I asked you to create either a pattern, a picture, or a random assortment of colored squares, and then to list some information in a table about the colors used, the number of each of those squares, and then fractions, decimals, and percents that would tell us how many out of the 100 were the colors used. This was the front side. It was the 10 by 10 grid, and I told you that we would do the 8 by 8 grid today, and so we will go ahead and do that today. But before I do that, I want to show you how I did my 100 grid, or the 10 by 10. It looks like this. Let me get a little closer here for you. There you go. I have gone ahead and created the figure pi r squared, which, if you don't know what that is, it's the formula for the area of a circle. And I've used 3 colors: yellow, purple, blue, and pink. The number of each, I had to get a little creative here to fit pi r squared and make it actually look like numbers and the appropriate symbols. So for purple, if we count the actual number of whole squares, I have 1, 2, 3, 4, 5, 6, 7, 8. And then down here, I've cut some squares into some pieces. These 2 pieces would equal 1 whole. These 2 would also equal 1 whole. So I have 8, 9, 10, and then I cut squares in half, or at least as close as I could to half, which would make 11, 12, 13, 14, 15. And as you see down on the bottom, I have 15 purple. For the pink, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, 12 for the pink. For blue, we'll count those: 1, 2, 3, 4, 5, and then these halves would add up to 6, 7, 8, 9, 10. And then in my 2, I have a few more: 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I could go ahead and determine my yellow if I added up the 15, 20, and 12 that I had on the others, because I should have 100 total. And if you count them, there are 53 yellows. I'm not going to take the time to. However, there are 53. I made sure. As a fraction, we set each fraction over 100 to begin with, because we have 100 total squares, and the number used would go over 100 as the numerator. So 53 for yellow would be 53 hundredths, or 53 over 100. It's already in simplest form, so I left it that way. For purple, I had 15 purples, which would be 15 over 100. It would simplify to 3 over 20. For blue, I had 20 blue, and when I put that as a fraction, it was 20 over 100, which simplified to 1 over 5, 1/5. And pink, we had 12 over 100, which simplified to 3 over 25. As a decimal, you can either get your decimal by dividing that original fraction, which was something over 100, or if you simplified, you would also get the same decimals. For 53 over 100, it would be 53 hundredths, just like the fraction sounds. For 15 over 100, it would be 15 hundredths, or 0.15, as we would describe it. 20 hundredths would be 0.2, 2 tenths. And 12 over 100, which again simplified to 3 over 25, both of those would be equal to 0.12, which is 12 hundredths. As percentages, you can either use the fraction over 100 to create your percent, or you can multiply your decimals by 100. In fact, I would probably write that down between the decimal and percent just to remind you. If you multiply by 100, it will allow you to create the percent from that decimal, and that would be a great thing to do. So if you have not yet completed the 100 chart, you need to do that and create also the table to go along with it. Check yourself. If you need help, you can ask someone near you that you feel knows a little bit more than you. That would be fine. Don't be ashamed to do that. And now I would like to flip over to the 8x8 grid. It looks like this. This is kind of more of a random pattern that I decided to put together. If you notice, I've got 3 colors listed here, but I actually have 4. If you take a look very closely, I have some blue, just regular blue, and then I also have kind of like a teal type color. And so we will list that as well. And pardon me if I can't spell teal correctly. Something like that. If it doesn't work for you, okay. Instead of teal, how about blue-green? That would work. That's probably more accurate. All right, the number of each. To fill those in, again, we just count. For blue, let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 blue. Orange, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 orange as well. Okay. So those fractions, decimals, and percents will all be the same. For purple, there are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 purple. Okay. And if we added 14, 14, and 17 up, that should tell us how many we need for the blue-green, but we'll go ahead and count them anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And let's just make sure we have enough. This 8x8 grid has a total of 64 squares. So I'm hoping that my numbers add up to 64. And if we go ahead and use a calculator, which for me, I will use my phone. (14) plus 14 plus 17 plus 19 does equal 64, so we counted correctly. All right, now that we have our numbers correct, we need to create fractions for them. To do that, since we don't have 100 total squares, we need to put our number over 64. So in doing that, blue would be 14 over 64. Orange would be the same, 14 over 64. I'll try to stay in the lines here. Purple, 17 over 64. And blue-green would be 19 over 64. Now, a few of these we can simplify. The 14 over 64 in both blue and orange, we could simplify. And in doing that, we would get 7 over 32 for each. And for both of those, that is the simplest form. 17 over 64 for purple and blue-green, which was 19 over 64, are both in simplest form already. So I'll leave those alone. To get a decimal, again, probably the easiest thing to do is to divide the numerator by the denominator with our fraction. In doing that, 14 divided by 64 would produce 0.21875. I'll go ahead and write down that whole thing. There we go. The same thing would be true when it comes to orange as it is for blue, because the fractions were the same. So even if we were to use the simplified version of orange, which was 7 over 32, 7 divided by 32 is again the same decimal, 0.21875. So that's good. The other two we can do very quickly. 17 divided by 64 would produce a decimal for purple. 0.265625. Okay. And we can go ahead and do the same thing for blue-green. Please remember blue-green was 19 over 64, so we'll put 19 divided by 64, 0.296875. So I'll put that up there, 0.296875. Now that we have that, we can turn those into percentages by multiplying again the decimal by 100. The reason I'm not going to use the fraction this time, notice they're all over 64. We want to put them over 100. 64 is going to be tough to make into 100. So that's where it helps to know that if you multiply the decimal by 100, it will create a percentage for you. So in doing that, let's just go ahead and do blue very quickly, which was 0.21875. We'll multiply that by 100. And it gives us 21.875. We'll put a percent sign behind that. 21.875%. We'll do the same thing for the other one. It's also going to be 21.875 in my case, because again, both the decimals were the same. So if we multiply the same thing by 100, it's still going to work. This one, which was purple, was 0.265625 times 100 equals 26.5625%. And the last one, blue-green, 19 over 64, which was 0.296875. If we multiply that by 100, 0.296875 times 100 equals 29.6875%. Now I know we haven't dealt a lot with percentages, especially percentages that do not have, or that actually have decimals, but it's okay. They still work out the same. And if we add all these up together, we should get 100%. I'm hoping that's the case. Just to double check ourselves, I'll take the 29.6875 as a percentage that we had. To that, I'll add the 26.56 to, I apologize, it's not a 7, it's actually a 5 on the back of that. I messed up. That is a 5. I wrote that down incorrectly before. 5, okay. Plus 21.875 plus 21.875. Let's hope it's 100. It is. So we have the perfect percentage because 100% of it was colored in. So 100% of it is colored with those colors. We are good. That's what I'm asking you to do today. If you have any questions, again, please ask someone near you that feels like they are comfortable with these things. And you can also ask the substitute as well, and I'm sure they would be willing to help you as best they can. Thank you for your time, and do the best that you possibly can. We will see you tomorrow.